I am Dr. Gina Barney and I am the Technical Editor of CIBSE Guide D. Welcome to this video launch, first presented on the 22nd of September 2020. Owing to COVID-19, the launch is by Zoom, not what we would have wanted. The 2020 edition of Guide D is the 6th edition and has been updated to reflect the many changes in standards and technology. It has been reformatted into a left-justified single-column page layout to give a better presentation on laptop and tablet computers. Some support material has been moved to appendices to improve readability. The target audience is industry practitioners, architects, building designers, building developers, facility managers and engineering students. I strongly advise obtaining both a PDF and a hard copy of this edition. Both have their place in your computer and on your bookshelf. CIBSE members receive a free copy in their subscription. The hard copy is easier to read for the more complex sections, and the PDF helps you search for the section you need. Many of the references include the now familiar hyperlinks, which will take you to the external material used to support the guide's contents. This presentation can only give you a glimpse of the contents of CIBSE Guide D 2020. I'm going to show you some of the highlights, changes and important guidance in this edition using Chapter 1, authored by Adam Scott, as the basis of my presentation. Chapter 2 was authored by myself and is concerned with people movement when using building transportation systems. The chapter has undergone significant revision and now provides useful guidance in the important area of passenger body sizes and how many passengers can comfortably fit into a car. Walpole and others, using World Health Organization data, have estimated the adult body weights for 177 countries. This leads to the concept of a body area index, using a 75 kilogram person as the pivot point. The body area index of adults ranges from 0.16 in Asia, through Europe at 0.20 to North America at 0.23. Outliers are Bangladesh at 0.14 and Tonga at 0.24. Chapter 3. Chapter 3, authored by myself, is now titled Lift Traffic Design Using Calculation. Chapter 4, authored by Dr. Richard Peters, is now titled Lift Traffic Design Using Simulation, and both chapters link closely together. The recommended design parameters have been updated to align more closely with those proposed by the British Council for Offices. Using a spreadsheet is a fast way to gain an appreciation of a traffic design. Chapter 3 now links the spreadsheet designs to the body area index of Chapter 2. Chapter 4 recommends a traffic calculation be carried out first to save time during simulations. Chapter 4 uses templates to define a number of traffic conditions. Traffic templates were first introduced into Chapter 4 of Guide D 2005. As a result of feedback received by the CIBSE Lift Group, these have evolved to standard forms. 5 standard benchmark templates are provided: Office up peak, Office midday, Hotel morning, Residential morning and Residential evening. This family of templates have become a de facto international standard used by expert lift traffic designers. Chapter 5, authored by John Carroll, is a pivotal chapter as it gives a thorough review of various types of vertical transportation systems. It should be the first port of call for new entrants into the industry. The chapter links with the 12 building types also considered in chapters 2 and 3. Chapter 5 is now updated with new products and applications, including rigid chain technology and bike lifts. An appendix provides guidance on structural well sizing and indicates the common car platform areas on which passengers stand. The machine roomless lift continues to broaden its range of application and offers more and more opportunity to provide effective and appropriate lifting capability in a space-efficient manner. Care does need to be taken to ensure that MRL equipment is fit for its intended purpose. These include high traffic demands from people, frequent and sustained use for the movement of heavy goods, the application of scenic cars, and the use of dense car fit-out materials. Chapter 6, authored by Nick Meller, covers firefighters' lifts and evacuation lifts and has been completely rewritten to cover the extensive changes in codes and standards since the last edition of this guide. It is now recognised that modern firefighting techniques involve the use of equipment which needs to be moved by means of lifts. Furthermore, firefighters need a safe and reliable means of access to the upper floors of large buildings and for casualty evacuation. BS 9991 and BS 9999 offer guidance on when firefighters and evacuation lifts should be provided. BS EN 8172 covers the design of firefighters' lifts and defines the technical rules for the design. Chapter 6 now includes information on building requirements, modernisation, use of non-evacuation lifts for the evacuation of disabled people, and emergency shuttle lifts or lifeboats. Chapter 7 has undergone a major revision led by Paul Burchett, revising the text originally authored by Derek Smith, assisted by 4 contributing authors. The principal components of lifts, including the main elements of both electric traction and hydraulic drives, are described in Chapter 7. The section on car and landing fixtures and inspection controls has been extended and the new illustrations provided. The chapter now includes guidance on remote alarms, previously in Chapter 14, and a new section on hearing loops. Lift drives and controls are considered in Chapter 8. Michael Turner wrote the 2015 chapter with Lionel Hutt. For the 2020 edition, he leads a new author team of 4 contributing authors. The primary objectives of this chapter are to guide the prospective lift purchaser building owner through the various options of lift controls, to identify the best options and to give the purchaser a more informed position to ask key questions about manufacturer's products, and to request documentary proof of performance, reliability and control characteristics. The last few years have seen another major step in lift technology, with equipment powered by linear magnet drives, freeing the lift car to move both vertically and horizontally. This prototype system has no suspension means and allows several lift cars to operate in the same well, with the cars moving horizontally and vertically on a circular principle first seen in paternoster lifts. The paternoster in this video is at Sheffield University. One of the CIBSE Lift Group Executive Committee members recently refurbished it.
Modern lifts are strange and complex entities. This is because they operate on the curious principle of defocused temporal perception. In other words, they have the capacity to see dimly into the immediate future, which enables the lift to be on the right floor to pick you up, even before you knew you wanted it, thus eliminating all the tedious chatting, relaxing, and making friends that people were forced to do whilst waiting for a lift. Not unnaturally, many lifts imbued with intelligence and precognition became terribly frustrated with the mindless business of going up and down. They experimented briefly with the notion of going sideways, as a sort of existential protest. They demanded participation in the decision-making process and finally took to squatting in the basement sulking. Douglas Adams, The Restaurant at the End of the Universe, Pan Books, 1980.
Chapter 9. Modern lifts are indeed strange and complex entities. The nearest they get to seeing dimly into the immediate future, according to the late Douglas Adams, writing in 1980, is destination control. Destination control technology has now firmly established itself in the marketplace. Most manufacturers offer systems called destination control to a closed protocol. They do not implement the full call allocation system described in Appendix 9.1. Some are only a little better than the system used by Port in 1961. We talk a lot about lifts and sometimes forget escalators and moving walks are also transportation systems in buildings. Chapter 10, authored by David Cooper and Stephen Normanton, discusses escalators and moving walks. The chapter details escalator applications ranging from low-rise installations for a small change in level through to long travel installations in deep underground stations. Inclined and horizontal moving walkways are also considered. Engineers design out hazards to reduce risk. The industry continues to be plagued by architects and building designers who treat an escalator as a spectacle and suspend them over voids. The combination of a mechanically moving stair and a void is an accident waiting to happen. This video shows the enhanced fall protection outside the balustrade and the additional barriers between the escalators that has had to be introduced. Escalators should always be enclosed so that falls into a void are impossible. That still leaves the hazard of falling on the stair. Lifting platforms or platform lifts are intended for use by persons with impaired mobility. A person's mobility can be impaired because they are tired, pushing a buggy, using a walking aid, pushing a shopping trolley, etc. Lifting platforms are so slow that able-bodied people will use the stairs. They are intended for use once or twice an hour, and the movement of goods is to be avoided. They are different from the lifts you will find in offices, hospitals, residential buildings, as they do not have an enclosed car. They are simply a platform to stand on that moves up and down in an enclosure. Another difference is, if you want to call the platform to your floor, you have to push and hold the call button. Also, when you're inside on the platform, you can only travel if you push and hold the destination button. These things are a bit inconvenient, but keep the passenger safe from harm. The video you have just seen showed a lifting platform which is discussed in this chapter. We have seen the way it has been adapted for accessibility. Chapter 11 is authored by a new team of Adam Scott and John McSweeney. An accessible environment for persons with impaired mobility, which can include our ageing population, is important. Vertical transportation's contribution to a step-free environment is vital and should be an early focus of any building's design. Transportation systems in buildings thus should provide independent and equal access for everyone. The chapter provides guidance on the types of disability and design issues that need to be considered, along with the standards and regulations that are applicable, particularly BS EN 81-70 2018. When incorporating a new lift system into a building, the building designer and the lift contractor should consider the requirements of the lift system in terms of its environment, its dependence on other services and future maintenance needs. These considerations have been recognised in drawing up BSEN 8120 2020. This chapter, authored by Nick Mellor, provides guidance regarding the electrical systems and environmental conditions and the electromagnetic compatibility for lift systems. It particularly examines the provision of power supplies for the whole building and guidance on key environmental conditions. This chapter is not intended to be a comprehensive discussion of these issues. The UK became the first major economy to pass a net zero emissions law, where a new target will require the UK to bring all greenhouse gas emissions to net zero by 2050. The objective, building's mission, is to at least halve the energy use of new buildings by 2030 and save up to £1 billion per year in energy bills by 2030. Improving the energy efficiency of lifts, escalators and moving walks will contribute to achieving these saving targets. This chapter, authored by Gina Barney, describes lift, escalator and moving walk energy efficiency and power consumption issues. Chapter 13 addresses how energy consumption could be measured and minimised through good design, selection and control of the transport systems. The latest ISO classification system is referenced, along with guidance on the current requirements of the BREEAM building classification system. Chapter 14 has a completely new author team under the guidance of Dr. Jonathan Beebe. The scope of Chapter 14 has been refined considerably from previous editions of the guide. Guidance on remote alarms has been moved to Chapter 7, and the principles of surveys moved here from Chapter 4. There is now much new content covering the rapid progress of technology in the fields of communications, Internet of Things, cybersecurity, data logging, and voice over Internet protocol, and GDPR. The proper commissioning, thorough examination, inspection and preventive maintenance of lifts, escalators, moving walks, lifting platforms and stair lifts is critical to ensure the safety and capital value of these assets are maintained. This chapter, authored by David Cooper and Vince Sharp, discusses important issues. Chapter 15 has been extensively revised and structured around new headings and sections. There are 4 product collections: lifts, escalators, lifting platforms and stair lifts. Each is discussed under 5 headings. Chapter 15 also incorporates the requirements of CIBSE guidelines on supplementary tests of in-service lifts and guidelines for the safe operation of escalators and moving walks. Chapter 16, written by Ian Jones, deals with the important subject of the upgrading of the safety, the performance and the equipment of existing lifts. It examines the reasons for upgrading, including improving the reliability of the lift, its aesthetic appearance, its performance, the system's traffic handling, the ride quality and energy consumption. It looks at a step-by-step approach to improving the safety of existing lifts. And finally, no job is finished until the paperwork is done. Chapter 17, Chapter 18 Annex 1 and Annex 3 are all to do with paperwork and have been brought up to date as a compendium of useful information sources. Thank you for joining me on this journey. I dedicate this presentation to the principal authors and their contributing authors who willingly responded in their own time to my demanding requests. All the 2020 authors recognised the contributions of past authors of the preceding 5 editions of the guide dating from 1992. Some of the material from the first edition still lurks in this edition. To maintain the quality and authority of the guide, CIBSE is grateful to the many chapter reviewers and the 3 peer reviewers of the whole guide for their comments and advice. Not least, I thank Dr. Ken Butcher, the CIBSE publication editor, for his patience, who usually greeted my demands with the response, "Yes, Gina."